Here's another equation that has a degree higher than 2. In fact, it's a fifth degree equation. Highest power of the variable is 5. We want to see if we can attack this equation in a similar fashion to the previous one. See if we can factor and then be able to solve from there. And again, I think I'll be able to because this equation is missing a constant. The only two terms it has have the variable. So I should be able to factor the variable out. But first I'd want to put that equation in what we might term standard form for a polynomial equation. Let's bring this 4x cubed term to the left side and have 0 on the right side of our equation. And I should recognize that both of these terms are divisible by x to the third. When I divide x to the fifth by x to the third, that leaves x squared. When I divide 4x to the third by x to the third, that leaves 4. And x squared minus 4 is also factorable. That's x squared minus 2 squared. That's the difference of squares. X squared minus 4 factors into x plus 2 times x minus 2. And I now have these factors that I can examine to see what value of x would make the factor become 0, because if you can make one of the factors become 0, the entire product will be 0, which would give us a solution because the left side would then be the same as the right side. So if x was 0, 0 cubed would be 0. 0 times anything is 0. Or if x was negative 2, this factor would become 0, and no matter what those values were when x was negative 2, 0 times any value is 0. Or if x was 2, x being 2 would cause this factor to become 0. And no matter what these factors became when we let x be 2, 0 times anything is 0, and we have our three solutions to that original equation. That's interesting. Typically, we think about the power of a variable as indicating how many solutions the equation has. If you think of your linear equations, they typically have one solution. Quadratic equations typically have two. This was a fifth degree equation, but it only had 3 solutions. The degree tells you the most solutions the equation can have. The equation doesn't have to have that many solutions, but that's the most solutions that it can have. So even though we had a fifth degree equation, there were only 3 solutions to this particular equation.